So given these two triangles, and more importantly, the information that they are similar, I'm able to make some conclusions. What I'm going to do is I'm going to just take those triangles out of the picture, because all I really care about is this information. If two triangles are similar, which is what this says, then all the corresponding sides are what? Proportional. Good. So if I take a ratio of sides, for instance, AB and EF are corresponding sides. If I take a ratio of that pair of corresponding sides, then that ratio should be equal to the ratio of another pair of corresponding sides. That's what proportional means. That corresponding sides are in the same ratio. What's the third piece that goes here? I did AB, which is the first two, and the first two. I did BC, which is number 2 and 3, and match those with number 2 and 3. So what's the third side? AC. Very good. 1 and 3, AC. And what does that match with? ED. Having now taken that information from here into here, I've got everything I need to solve this problem. Instead of AB, in our current problem, what's the length of AB? 9. So I'm going to replace that with 9. What's EF? Those two are now corresponding sides, and I'm saying that their proportionality is consistent with what I see here. BC is Y, FD is 12, and AC is 8, and ED is X. And again, now all I care about is this. How weird to have two equal signs. This isn't a normal equation, is it? But I could block that out and treat this as an equation. Is that an equation I want to try to solve? I mean, maybe if I'm a glutton for punishment, but how many variables are in that equation? 2. Is it possible to solve a single equation in 2 variables? Can you find one answer, like X is always equal to this? No, you can only find a relationship between them. It's easier to see with this one. What if Y were 12? What would X be?
4.
You're right that 12 over 12 would give me 1, but what would X have to be to make 8 over X equal to 1? 8. So do you agree that a solution of Y equals 12 and X equal 8 would work for this problem? What if Y were 24? So the ratio is 2 to 1. What would X have to be? 4. What if Y were 6? So the ratio is 1 to 2. Hi, are you Cassandra?
Yeah.
Come on in. Back row, I think. Nick, is it true that this far seat is unoccupied?
I think Sophia's the male, and then these two
Are both empty? I thought we had somebody else. We got a couple absences. Yeah, you can sit either right next to Nick, which might be a good idea today, just so you can kind of get a handle from him. Introduce yourself to him. This is it Cassandra or Cassie? Well, you're introducing yourself to class. Which would you prefer them to call you? Cassandra. Please welcome Cassandra. She's joining us from Redwood. Give her a relatively light, easy landing spot. It's hard to change classes in schools, of course. So again, when we have 2 variables in an equation, it's impossible to solve it. So let's not set ourselves up for failure. What if I blocked this out and created that as an equation? Is that solvable? Yeah, that's just one variable. So that's what we're going to do. We're going to take these 2 things. And Cassandra, this is just a little intro opener, getting our heads going, and then we'll use that document in front of you. So I'm going to say 9 over X plus 2 equals 8 over X. And this is a proportion, ratio equals ratio. So I solve it by doing what? Yeah, cross multiply. So 9 times X equals 8 times X plus 2. I'll distribute, and I get 9x equals 8x plus 16. Subtract the 8x, and I get x equals 16. Easy peasy. Now, what that shows us that is if x is equal to 16, and this is related to 8, right? These are corresponding sides. What's the scale factor going from this triangle to this triangle? 2, which doesn't surprise us. When we take 9 and multiply it times 2, we get 16 plus 2 is 18. That seems to work. And so intuitively, we could then find out what y is. If the ratio is 1 to 2 and y matches to 12, what's y going to be? 6. And we could find it algebraically by taking two equations, one that includes y, like y over 12 equals 8 over, but instead of x, we got to use what we solved as the x value. Cross multiply and solve, 16y equals 96. Divide both sides by 16 and we get y is equal to 6 like we predicted. Does this make sense? 5, this makes perfect sense. One more tool in my tool belt. 3, as you went through it, I was with you along the way, but I wouldn't be able to do it myself. 1, I'm confused by this. You use pencil and pen, isn't that illegal? Okay, good, hands down. In front of you, you've got a packet. In that packet, you'll find that the first page has some problems that begin the same way. It gives us a similarity statement. And that similarity statement is going to help us, but only in as much as we'll use that to create the proportions. Then we kind of throw this part away. And we'll fill in the necessary parts from our problems here. And then we'll cross multiply and solve. I do want to see all of this work on these pages. So for example, look at this and tell me what I would make as the first side out of here. What side should I put on top here? PQ, sounds great. Once I establish PQ, what matches to it? What goes underneath it? CB, because they're 1 and 2, 1 and 2. And now I need a second side from this. What should I choose? I hear some chatting. You guys must have discovered that some of you don't have this problem. That's intentional. There are two versions of this today. You'll notice in the upper right-hand corner, it either says ID2, in which case you're looking at what I'm doing, or it says ID1, in which case you're looking at a very different problem. Today, as soon as I finish this modeled example, you are welcome to ask for help during this, but you may only ask for help from somebody who has the other version. In that way, they can't tell you the answer. You can't copy from them. Instead, you can say, oh, well, this is what I would do. I've chosen the first two letters, P and Q, from the left, and then I choose the first two letters from the next one, C and B. And then I choose second and third, Q and R. And so from here, I'm going to choose what? Good, BA. What's the third side from PQR? RP, sounds great. And once I choose RP, it forces me to know what goes here. What goes here? AC. I want this to be the first step. Please do not cut corners and not do this part. The second step would then be to say, let's take each of these values and plug them in. What do I know about PQ? It's 24, so I'll replace PQ with 24. What do I know about CB? 6. What do I know about QR? It's a question mark. Honestly, I think that's a little weird. Let's change that to X. That's our variable. What do I know about BA? 4. What do I know about RP? It's blank. Can I call that X? Excellent. Exactly right. I've already assigned X to this length. If I put an X here, it's going to mess things up. It's going to force these to be the same. But more importantly, I got no information on RP and I've got no information from AC. This ratio is not part of my issue. All I needed was two ratios. one proportion. So that's what I've got here. I'm going to look at these and I'm going to solve it like a proportion, which means cross multiplying. 6 times x equals 4 times 24. 6x equals 96. X equals 16, and I'm done. What I've just discovered is that length RQ is 16. Any questions on that process? Those of you that didn't get this version, your first problem is kind of trivial, isn't it? Because the two triangles are actually congruent. Well, excuse me, the two triangles are both isosceles. Therefore, your ratios are going to come out the same. Well,
How do we know X is like you?
well, we took the question mark up there and we replaced it with X just because we don't like having question marks in our solutions. You could leave it as question mark, you could leave it as RQ, whatever you want. All right, what I would like you to do, please, is finish this page. Make sure that you're showing the proportions, you're doing the substitution, and then you're solving it using cross multiplication. The top part is exactly like what I just did. The bottom part's the same with just a little bit more algebra. Please do this for about the next 10 minutes. If you're going to talk to somebody else for help, that's okay. Make sure they have a different version than you. A go. Okay. I'd like to move on to the second part, please. Pause what you're doing with that first warm-up page. Let's move on to this page. In the event that I'm looking at triangles, sometimes we'll find that we have triangles where this second triangle is formed by adding in a parallel line here. And just as we talked about in the warm-up, does that force these triangles to be similar? Or are they just two buddies hanging out? What does it take to say these triangles must be similar? It's got to be one of those three things, right? Did I give you any side lengths? So unlikely we're dealing with either of these. Are these two triangles similar by angle-angle similarity? Do you have any angles that are similar or congruent? Excuse me.
They share an angle and they're also alternate.
You guys agree they share this angle, reflexive? And I like what you were saying about the alternate interior. I think what you're saying is if these lines are parallel, then this can be thought of as a transversal, and we can see that there are some angles that are in a special relationship, but I don't think it's alternate interior.
Sorry, corresponding.
Excellent, corresponding, exactly. But your idea is right. We can prove these angles are congruent because the lines are parallel. We have a shared angle here. Therefore, these two triangles are similar. And we did something a couple of days ago where we had things like this. And we were asked to set this up. How did we do it? Do you remember? Kevin? Oh, you're remembering something else. It does have to do with coming across here. That was when we had this and this distance be the same, when it was a midpoint connecting to a midpoint. That made a mid segment. And this length was the average of the top and the bottom in a trapezoid, or half. But this is about these side lengths. I call this the side splitter theorem. And we had an ability to do it before. We could have done it that way and said, okay, in my little triangle, I've got 10 here and 12 here. How long is this side?
15.
Good. You see that it's 10 plus 5, it's 15. How long is this side?
12 plus X.
Very good, 12 plus X. And now I could create a ratio. I could say that if I'm taking the little triangle to the big triangle, I can say that 10 is to 15 as what?
12 into 12 X.
Good. And that'll totally work. You can continue to use that idea. But today, what this worksheet is about is there is a shortcut we can use. If I have this scenario, these lines being parallel, thus these two triangles are similar. And I know that this is A and this is B and this is C and this is D. Then I can still do exactly like we did up here. I can say that A is to this sum, A plus C, as B is to B plus D. Right? That's exactly what we did right here. Then I'm going to cross multiply. And that's going to give me A times B plus D equals B times A plus C. I can distribute. And you notice that both sides have an AB on them. So I can subtract that from both sides, make them go away. And I'm left with AD equals BC. Yes, so what, Mr. Erlin? Well, I'm going to divide by CD. Why? Because I can. When I do that, the D's cancel and the C's cancel. I'm left with A over C equals B over D. What that means, I'm going to write it up here for us so we can see it easier, is that if I'm given this scenario where I've got parallel lines here, such that this side has been split into A and C, and this side has been split into B and D, that the way they're split is proportional. A to C is the same as B to D. This is this piece here in the triangle proportionality. It says that if these two lines are parallel, if DE is parallel to AC, then we know that the ratio of the sides split, the BD over DA, will equal what? Excellent. This split is going to be proportional to this. It's not that BD and BE will be the same, but that the ratio of this to this will be the same as the ratio of this to this. And it turns out the converse works as well. If in fact they are split proportionally, then the line that split them must in fact be parallel. I find this theorem a little bit cumbersome, but the application of it's pretty straightforward. Do we see here that these lines are parallel? That's what the little arrows mean, right? And if these lines are parallel, then I can say that they're split proportionally. So I can say 12 is to 14 as what? 15 is to X. That gives us our proportion. When we have a proportion, we can solve it by cross multiplying. 12 times X equals 14 times 15 divided by 12. 3 is 5, 2 is 7 is still a 2, so 5 times 7 is 17.5. Green is kind of hard to see, isn't it? Any questions on number 1? Using the triangle proportionality theorem to find missing parts. Okay, take a look at number 3. Slightly different. Do we have parallel lines? Yes, therefore we've got 2 similar triangles. So we can set up a proportion. Would somebody like to suggest what proportion we can use? Yeah.
X is to 36, what, 10 is to 45?
Really good. You caught the twist here. Because X is the part formed by this parallel line, my corresponding side on the right has to be this little chunk, not the whole 55. So what I think she did is she said 55 minus 45 is 10, and that's what I know this length is. So she said x is to 36 as 10 is to 45. Is there another way you could have done this? Yes, we could have recognized that we wanted to deal with the 55 and the 45. If we had done 55 to 45, that would have meant what on the right-hand side here?
36 to 36 plus that.
Yes, except you're upside down, right? The 36 is aligned with the 45, so that belongs down here. And then this whole side is what matches to 55. Either one of those would work. This, of course, is just using similar triangles. This is using what we're calling this Triangle Proportionality Theorem or the Side Splitter Theorem. So I'm going to ask you to do this page using the Side Splitter Theorem. When you get to the back page, you'll discover that the top is just asking you to do the inverse or the converse, excuse me. In other words, determine if the lines are parallel, which means we have to see if they're proportional. So how would I set up number 7 to see if it's proportional? Good.
Wait, and then after you solve it, would you just see if it's true?
Yes, exactly right. We've now created a proportion. If we want to validate this proportion and see if it's true, we just do the cross multiplication. And if we do it right, 10 times 15.4, we get 154. 11 times 14, oh, that's 10 is 140 plus another 14 is 154. The fact that they're equal to each other tells us, yes, MN is parallel to JL. Any questions on using the converse of the Triangle Proportionality Theorem? Yeah, well,
I don't know what
how do you know which one goes on top? Good question. The first one is free. Like whatever you choose as the first number to work with is totally free. You could have chosen 11, 15.4, 10, or 14. The second one you choose matters. If you chose 11, you've got to put it over 15.4. And then you have to make this one match. In other words, 11's got 2 components to it. It's part of the little triangle and it's on the left side. So the number underneath it has to be either part of the little triangle or on the left side. So we could have said 11 over 10 equals 15.4 over 14, but you would not have been able to match 11 with 14. Those don't have anything in common. Other questions? All right. Turns out that conceptually, couldn't these lines continue up to make a triangle? And so that if we had multiple parallel lines, we'd get the same interaction. That top little piece to this would be the same ratio as this to this. And the top little piece to this would be the same ratio as this to this. Which means anytime we've got parallel lines, AB parallel to CD parallel to EF, the gaps produced are proportional. So AC is to CE as what? AC is to CE. What's the other ratio? Very good. BD, because it shares this segment gap with AC. They've got something in common. And then CE shares with DF, so they've got something in common. These have something in common because they're on the left side. These have something in common because they're on the right side. And so you'll be solving these problems the same way as you did on the other side. It's just not triangles, it's parallel lines. One more thing to show you, back page. If 2 triangles are similar, then we know that the ratio of one pair of corresponding sides would be equal to the ratio of a second pair of corresponding sides, would be equal to the ratio of the third pair of corresponding sides. In other words, any side would suffer the same scale factor change. Turns out it's not just sides. Remember when we did centroids and incenters and circumcenters and orthocenters? And we talked about an altitude, meaning it's perpendicular to the base, and an angle bisector when it bisects the angle, and a median when it goes to the midpoint of the opposite side. Turns out, if these two triangles are similar, and I were to take a ratio of corresponding sides like AB to EF, that effectively finds the scale factor, and that same scale factor would apply to the altitudes. So what goes on top here? When I created this pair, I've chosen that I'm going to put like the bigger triangle on top and the littler triangle on the bottom. So if I choose a corresponding side from the big and a corresponding side from the little, they'll be in the same proportion as any other corresponding side. They'll also be the same proportion as the altitudes. So what's the altitude of the big triangle? Yep. Or BD. And what's the corresponding one here? HF. Same with angle bisectors. I'm going to pick a pair of corresponding sides. Let's go QP and UT. That scale factor, that ratio, is going to be equal to what? Good. QS and UW. Nice. Please write the last one yourselves. You have to pick corresponding sides. And I know it's a little imprecise in the way this worksheet is presented, that it doesn't tell you what the corresponding sides are with a similarity statement. That would be better. But what would you guess is corresponding to GH? I would agree. And now we're going to set that equal to the medians, which would be whatever what. Perfect. Could you have done it with the other side and done HI over LM equals HJ over LN? Sure. Could you have done those upside down? Yeah, as long as you're consistent. Any questions? All righty. We have 48 minutes left in class. In that time, you can work on this worksheet, finish these up, submit these in Canvas as your homework. In addition, this is a great day to take the test. If you haven't taken all 3 of your attempts, or you haven't started that process, this is the day to do it. In order to do that, number 1, put your phone up in the calculator caddy over here. Get it away. 2, come up to me and say, Mr. Erlen, I'm ready to take the test. Wait for me while I acknowledge you and put your name in. And then 3, sit down with your Chromebook and take the test and do not interact with anybody else. All right, rest of you can work on the worksheet.